We're very, very happy to be here, and from what I've heard, this isn't the main event. It's just one of a series of very great sessions that I think hopefully for all of you will add up to kind of a new understanding of this phenomena that we're talking about, which some people call IoT, some people call the industrial internet. But what we have done as we've been working in this area for the last 3 or 4 years very deeply is actually to call it smart connected products. The internet is old news. Connecting things to the internet, that's not different. What's different is the different nature of products and what they can do. That's what's changing. That is the discontinuity. What we've been trying to understand is, what does this actually mean for competition, for strategy, for the choices that companies need to make, starting with manufacturing companies who make things, who make products that are going to change. But those choices all filter into service industries as well, because service industries are going to use these smart connected products. And if you got a connected airplane, you can run an airline differently. So the kind of first question we were trying to understand is, first of all, what are these things, but how do they affect competition? And how do they affect how companies actually operate inside? Clearly, they affect the outside of how companies compete in the marketplace, but how do they affect the inside? And we've had a very kind of unique partnership between a university, HBS, and my team there, and PTC that has long been a leader in products, in the design of products. Its original product was ProEngineer. It was a breakthrough in CAD. PTC has been deeply connected with manufacturing companies and their products for many, many years. And I, till recently, was a board member of PTC. And as a board member, we were seeing this thing happening. And Jim and I decided that this was worthy of a serious body of research to try to understand deeply what was going on, not just descriptively, but in a way to try to provide some framework for thinking about this and some insight into choices. Choices that organizations had to make. Now, out of this work has come 2 now so far Harvard Business Review articles. Hopefully, some of you have read them. One is on competition, the other is on companies inside. More is on the way because this is one of those moments in industry and in companies that I believe truly is a discontinuity. This is the biggest thing happening to competition that I see for the foreseeable future. There'll be other things that matter, but this is the thing that I think has the most ability to change the game. And so what we'd like to do today is try to give you an overview of what we've come to understand about this phenomena, what it means, show you some examples, do some demos, but most of all, try to develop some of the implications for what this all means. And in order to do that, I think we have to put this in context. What's been going on now for a very long time, probably 80, 60, 70 years, is the penetration of information technology into the firm and into the economy and into competition. If we go back far enough, products were mechanical and electrical and electromechanical. And the way in which companies operated internally in the value chain was manual, and it involved processing paper and communicating verbally. That's where we started. That was the nature of the firm and the nature of the product, if we go back far enough. But starting in the 60s and 70s, the IT, the revolution, this new set of technological capabilities started penetrating the company, penetrating the firm. And we see there have been two eras so far, and this is the third. And in many ways the most important. The first era was what we call value chain automation. What happened was when you had computers and you could bring information processing into the company, what happened was companies automated the various parts of the value chain. Automated order processing, automated kind of manufacturing resource planning, automated CAD, automated design. Information technology enabled us to kind of automate the various pieces of what the company did inside, in the value chain, and that led to a tremendous improvement in productivity. By automating CAD, we could do CAD a lot better, we could do it a lot more efficiently, and that whole opportunity swept across every company virtually in the world, and what happened was productivity went up. As you all probably know, what's been well established is that what's been driving productivity growth in the economy all over the world for these last 30 or 40 years was heavily this IT transformation. And the first wave was a big deal. And it took decades to play itself through the industrial economy and through the business sector, and it had a profound effect. Then, however, technology continued to improve, and we went into a second wave. And this is what we call value chain dispersion and integration. And this was really enabled by the internet. Cheap connectivity, ubiquitous connectivity. And what this allowed us to do was take the individual parts of the value chain, and we're still inside the firm at this point, the individual parts of the value chain, and start to connect them together. And not only connect inside the firm, but connect outside with the suppliers, with the channels, with the ultimate customer, with other locations in a geographical configuration of production or supply. This gave rise to things like supply chain management, SCM, customer relationship management, CRM. In the world of PTC, PLM, product lifecycle management. All of these were breakthroughs that, again, led to big improvements in productivity. And the productivity growth continued to be robust and strong in the economy, not only in the US, but in many other parts of the world. Now I think it's well established, though, that these first two waves have petered out. Productivity growth has been slow and even declining for the last decade or so. But now I think we're starting to see the next big driver, and that's what we call smart connected products. Now, instead of IT being embedded in the value chain, in the way the company performs the activities of competing, now the IT has become embedded in the product itself. Software, sensors, and a whole family of other technologies that Jim will talk about in a moment. And what that's done is that's created a number of very powerful effects. One, of course, it's changed the value created by products. Products can do more things, they can do new things, they can create value in very many new ways. And we'll talk about that. Number two, as was mentioned by our previous speaker, the products now are spitting out data. And that new kinds of data, we had data from the value chain. We knew how many orders we processed. We could do all kinds of data analysis inside the firm, but now we have a product that's out there collecting data outside. You can think of a product as a sensor that's collecting data about how that product is used and what happens to it every moment of every day, if we want to collect that. And that data is allowing some new things that we could never do before. But these smart connected products don't just affect what products can do and how we compete. We're now having yet another transformation of the inside, the value chain. And as we'll see a little bit later, in the world of smart connected products, just about everything in the value chain is different. The way we go about product development, the way we go about marketing, the way we think about manufacturing, the way we think about after-sales service, all those parts of the value chain are undergoing a transformation that's enabled by the different product characteristics that we see emerging. And in many ways, the change inside companies is bigger now than the change we saw in these previous generations of IT. We all went through the exercise of, an SAP installation, which was kind of this highly disruptive thing that costs a lot of money. I understand SAP people are here, and it's a great company. But most people, were it was a painful process to kind of redesign all that stuff in order for SAP to do its magic. Well, this is even more challenging. Because what a salesman does, what a marketing person does, what a product developer does, all those jobs are changing in a fairly substantial way. And we'll talk about that a little bit later. So what Jim, we'll turn it over to Jim now. And I think what we'd like to start with is sort of giving you a somewhat kind of holistic view of what is changing in the product and what products can do. And then we'll go from there to think about, okay, what does that mean for competition? And competitive positioning and competitive advantage. And how does that then affect strategy? What are the strategy choices you have to make in this world, whatever industry you're in? What are the types of new strategy choices that we see? And then we'll turn to the value chain. How does this really affect the value chain? We will look at everything, but we'll try to pick 5 or 6 key areas and kind of give you what we're seeing, what we're learning. And then we'll wrap up with organization. How does this affect the way we organize? We basically haven't had a change in the organization structure, particularly in the manufacturing firm, for the last 100 years. But we are actually starting to see a change in the classic functional structure of a manufacturing business today. And we'll talk a little bit about what some of those organizational changes look like. So Jim, let me turn it over to you with your tennis racket.
Yeah, great. Thank you, Michael.
And we'll dive into these products.
Can I get the clicker from you? Thank
you.
So a good place to start is to baseline everybody on, what is a smart connected product. And I realize there's a lot of experts in the room here. But still, we're going to make some points later that tie back to this, so I think it's worth going through this quickly. And it's fun to use a tennis racket because this happens to be a smart connected tennis racket from Bobbilette. It's the Pure Play Drive Bobbilette tennis racket. And ever since people played tennis rackets were mechanical, physical products. So what happened? What happened that a tennis racket became this new smart product? Well, what happened is inside the hardware, the frame and the strings and so forth, Bobbilette placed sensors, principally in the handle here. So in this handle, there are vibration sensors, there's accelerometers, there's electronic gyroscope, there's a little microprocessor running a bunch of software, doing data transformation to convert these accelerometer and gyroscopic signals into backhands and forehands and serves and understand the speed and the angle of the hit and where did the ball hit on the racket and so forth. So that's the data we're collecting by running quite a bit of computing in the handle of this tennis racket. It's really pretty interesting because it's actually hard to know. It doesn't feel different. It doesn't really look different unless you look very carefully at the bottom here. So what you'd see if you study this thing is that there's a Bluetooth connection in the hardware-software product at the bottom of this stack that connects to your phone and from your phone through the internet up to some cloud somewhere that has a lot of technology in it. And if you follow that thread, when you get up to the cloud, you're going to find a database that's tracking all of the activity from all of the tennis rackets that all of the customers have purchased. And so it's aggregating all this data together as it streams in. And because it's streaming data and it may be quite unstructured, these tend to be big data databases. Now, there are many things we can do with that data in the database. So we'll want to develop applications, not just one application though, maybe dozens, could be hundreds of applications. So we'll probably want an application platform up in the cloud as well. Now it turns out that the data as it comes in its raw form has some utility, but we could perform analytics on that data and run rules against that data and learn a lot more. We could derive a lot more value than just the number of strokes in a tennis match. So we want to run analytics in the cloud, and we'll talk a bit more about that later. And then based on this data and the platform and the analytics, we're going to want to develop applications. Applications that run in a web browser on your laptop or on your smartphone or your tablet. And then there's a new way we're going to introduce that we see people building applications, which is with augmented reality experiences. And I'll come back to that when I have some better examples. So that's the basic idea of a tennis racket. Now, that's a very different tennis racket. It turns out that the engineering process for this tennis racket is very different. It involves standing up a whole cloud architecture. And how many engineering teams know how to do that? Not very many. They may have figured out embedded software, but how do you secure a cloud and worry about failover and scalability and security? And I mean, that's a whole new set of things that IT departments know something about, but engineering departments know very little about. Now, we can't just develop applications that talk to the tennis racket because we want to pull other data in. For example, we might have a CRM system that knows who bought the tennis racket, and I want to get the customer record and use that in the application. And maybe I have a PLM system that has the design of the record, the configuration or some design information that I'd like to pull into the application. Maybe I also want to look at external data sources and compare how weather affects game performance. So I want to get weather feeds from an external source, combine it with the time and the location where the game was played, and see what's going on there. So really, this becomes a pretty sophisticated piece of IT technology that still looks and feels like a tennis racket. Now, I need to comment on this, and it's a whole treatise in itself, the idea of identity and security, which is because it's now a sophisticated IT system, it has all the same vulnerabilities and then some that every one of your other IT systems has. And so now we need to think about how to secure this. How do we keep people from intercepting the data? Do you want your competitor to know what your game looks like? No, probably not. How do we keep people from spoofing that they're a tennis racket and connecting to the cloud and stealing data or sending bogus data up there? So there's a whole new set of issues that certainly are going to affect the engineering of this, but as well the manufacturing, the use, and so forth of a product even as simple as a tennis racket. So just to pick up on the data idea for a minute, we have data coming from the tennis racket, and we have data coming from external sources, and that brings us to this concept of a data lake. Now, a data lake is simply a huge place to aggregate data, and it's called a lake because what flows into a lake streams. So a data lake is a place where data streams aggregate. And again, it's unstructured because just like a lake may be fed by different streams, one running off the mountainside that's cold and clear and another one coming up the valley that's warm and muddy, we need to be able to accommodate all this data, and we're not going to be able to jam it into rows and columns in a typical database because we'd have to throw too much of it away. We can't really figure out a schema that works, so we're going to use big data technology. And so we're going to take all the tennis racket streams from all the tennis rackets that are telling us what's going on, what's the condition of the racket, how's it being used. We're going to look at external data, what's the weather, the demographic of the users, and we're going to look at internal systems, CRM systems, things like that, what's the design of the racket, and so forth. And we want to study this data and see what it's telling us that's not obvious, and that brings us to the subject of data analytics. Now, this is another place that most manufacturing companies don't really have an organization that does data analytics. And yet, from these data analytics, we're going to learn things that could affect engineering, manufacturing, sales and marketing, customer service, you name it. So we're going to have to figure out how to use some combination of computer science and mathematics and business analytics to find all the hidden gems in this data that helps us understand what happened with descriptive analytics, why did it happen, like what's the root cause with diagnostic types of analytics, maybe what will happen next with prescriptive analytics, and what should I do to ensure that that good thing does happen or to prevent a bad thing from happening with prescriptive analytics. So this is a very interesting field that represents a whole new dimension that most manufacturing companies are sort of ill-equipped to deal with in their current configuration, but is very, very important. So now that we have all this data coming from the product and we're analyzing it and learning lots of interesting things, we might learn, for example, which instructional technique or school causes the capability of the player to accelerate most quickly for this design versus that design. What's the best way to teach tennis players? Because we're looking at instructional techniques that we maybe got off the profile. Maybe we asked the player, who's your teacher, or what school do you belong to, or what instructional technique do you use, and we're comparing that to learn all kinds of interesting things on a regional basis, a product basis, you name it. And so we're taking this data and this capability, and we're realizing we can do a lot of new things now that we couldn't do before. So the first thing we can do is we can monitor what's going on. And by monitor, I mean simply know at any point in time, where is the product, what's it doing, what sort of health or condition is it in, and what sort of environment is it in to the extent we can measure that from the product. And that's a powerful idea because for the first time ever, Babolat knows what people do with tennis rackets. That's a powerful piece of data to have. Now the tennis rackets story kind of stops there because it turns out, at least to this point, they haven't figured out how to control the game, and maybe that's a good thing. But the next thing you could do, you'd say, well, if I can get data from this smart connected product, can I send instructions to it? And could I actually create a control loop, a remote control loop in particular? And with this control loop, could I turn it on, turn it off, make it go faster, slower? Could I customize it or personalize it? A simple example is the iPhone app that works with the Philips Hue light bulbs. You can turn the light bulb on and off, but you can also change the color and the intensity and even create a mood setting and all kinds of interesting things, with a simple light bulb. Now, if I could control the product, I could get a little bit more sophisticated yet, and I could say, let's put algorithms and analytics into the control loop. Let's have smart controls. And a good, simple example of smart controls that I like is when I go into a high-rise building in San Francisco or in New York City, you used to push the up button. Now you say what floor you want to go to. And it figures out what is the best way, which elevator is the fastest way to get this person to that floor with the least inconvenience to this person and to all the other people trying to get to all the other floors. What's the optimal way to run this bank of elevators, for the benefit of everybody? So we can optimize the operation. We can optimize the utilization. We know when products aren't utilized, we can pull them in. Richard can pull those Tesla batteries into the loop and use them for overnight storage of electricity and so forth. Lots of interesting ideas. We can also, though, optimize the availability of the product. We can predict when problems are going to happen and prevent those problems from happening. And to the extent a service call is needed, we can try to do it during an off period when we're not going to impact production versus an unplanned outage that might, shut a whole factory down. So as we get more sophisticated with optimization, we could take the final step and tell the product, you decide. Start making your own decisions. Here's a lot of data, a lot of algorithms. You decide what to do. There's a fun little example here of a Boston company called Boston Engineering. It's a fish robot. And this robot's designed to go down to the ocean floor, pick up something, and bring it back up. And it's shaped and designed to work basically like a tuna. That's a very efficient fish. Now, what they want to do is just say, it's down there somewhere. Go find it. And navigate around rocks and obstacles and figure out how to fight currents and depth changes and so forth. I'm not going to tell you that. Just figure it out as you go, retrieve the object, and bring it back to me. So, that's a fun example. Of course, there's the Google car and so many other examples of things that are becoming more and more autonomous. But a good example of autonomy is what's happening with Industry 4.0, where we're trying to give factories more and more not just optimization, but even the ability to make their own decisions around, reconfiguring production capabilities and so forth on the fly. There's also some interesting examples of autonomous service. I have in my home a water filtering system that decides on its own when to do a backwash to flush the filter out. Which I always think is kind of interesting. Just every once in a while, it services itself because it's now capable of making that decision on its own. So lots of important things, lots of important breakthroughs that are going to affect strategy and operations of the value chain here in a minute. Now, one of the things that Michael and I have been working on recently is this new idea of augmented reality. And it comes from the basic idea, if the tennis racket is part digital and part physical, how come the modes in which I interact with it are purely physical or purely digital? Isn't there some convergence actually of the way I interact with that product that is at the same time physical and digital? And that's really where augmented reality brings us, because augmented reality means to take digital information. For example, where did the ball hit on the racket surface during the last game? Map all the ball hits onto that racket surface visually. So go get the data up in the cloud, bring it down, and when I look at that tennis racket, put that information in my field of view. Augment the reality that I see with digital information. It's a big, powerful idea that will really, I think, change the way that we think of, design, and interact with products. Now, this just fundamentally takes those capabilities I've talked about and juices them up a little bit more. So, for example, this allows us to enhance your understanding of a product. You can look at a product and basically with X-ray vision see deep inside that product where there's a component or a subsystem that has a problem, and it's glowing red. Now, you can imagine in medicine, you'd look at a human and you'd see that the spleen is, red. There's a problem there. Lots of interesting ideas like that. We can create hypothetical views. If you want to put a deck on the back of your house, I can show you what your house will look like with a deck on it. You can change the configuration of the deck, and I'll show you what the house would look like with that new configuration by simply augmenting the digital version of the deck onto the physical view of the house and including visibility where necessary and so forth. So it enhances our ability to see things that don't really exist. It also enhances our ability to visualize information in the context of the product. Again, I could imagine, and there are many applications that you run on a phone or a tablet where you look at the phone or the tablet, and then you look back at the product, and then you look at the phone or the tablet. But couldn't I look through the phone or the tablet at the product? If you've played around with smart glasses, all they are is see-through computers you wear on your head. So you look right through the screen. And so simply by putting information on the screen, that information enters the picture that you see with your eyes. It's a powerful idea. So we can put a dashboard onto a product that doesn't have any user interface. We can put one on there. It's no problem. We can also put controls. We can put a sophisticated control panel on a blank sheet of sheet metal. That means we could actually design products differently. We wouldn't have to design controls into the product. We could simply augment them on after the fact. And then we could also instruct people in what to do in terms of a process or a procedure. Let's say you're trying to put something together on a manufacturing floor, like that airframe example that Richard was showing. We can show you exactly what the next step is, where to put the part, how to attach the fasteners. Or if you're a service technician taking something apart to repair it, we can show you exactly how to take it apart with a step-by-step process. And we can watch over your shoulder. We can have somebody 1,000 miles away seeing what you see and marking up, providing coaching in your field of view. See this thing right over here? That's a gallbladder. Stay away from it, okay? That kind of idea. So this concept of augmented reality is simply bringing to the way we interact with products the same digital physical convergence that's happened to the product itself. So it's just taking these capabilities to another level. Now, I want to bring Michael up here again, and he's going to talk about how all these capabilities really affect strategy. And he's going to use the famous Porter 5 Forces. If you have an MBA, surely you studied the famous Porter 5 Forces. It's one of the foundational building blocks of teaching business strategy, and it was invented by Michael, and he'll use that framework to talk about competition.
Thanks, Jim. Well, Jim's tried to give you a flavor for what these products are like, what's in them, what technology surrounds them, what can they actually do, and This role of augmented reality, I think, is a powerful and very early emerging dimension of this that I think will prove to be quite important to the overall picture. The question is, if you have products like we just talked about, with the capabilities that they have, with the data that they're generating and potentially analyzing, how does that actually affect the nature of competition in an industry? In the car industry, in the HVAC industry, in the tennis racket industry. How do we think about that? And in order to do that, of course, we'll draw on a framework for looking at how do we think about competition in any industry? What are the kind of fundamentals of drivers of competition? And that's where this notion of the five forces really came from. It's an attempt to really have a sort of a deeper, more fundamental view of what competition fundamentally is looking like that we can then apply to any particular industry. And the five forces, really start with the rivalry between the competitors. So, how are car companies going to compete differently if they have smart connected products? In terms of pricing, features, functions, how are they going to compete differently? So that's one question. Are there going to be new substitutes? Other products that can actually disintermediate the product we're producing. They're very different products. They're produced by different people, but actually they can compete effectively with the products we make in our industry. You think of plastics versus steel. Those are substitutes. They're not the same. They're not the same product, but they compete. One is a substitute for the other in many applications. What's that relationship with the buyer? What's going to drive that relationship? How is that relationship going to change? Is the buyer going to have more power in a smart connected products world that's buying your product, or less power? How do we think about that? Will that buyer be more price sensitive, or will that buyer be less price sensitive? How do we think about that? Then we also have to think about suppliers. For most of us, a big part of our cost structure is not stuff inside us, it's stuff we buy. It's all kinds of components and technology and parts, and actually we're also paying workers. Labor is a supplier. And so how is the smart connected products going to shift the relationship with suppliers and the mix of suppliers and who we're buying stuff from and what that looks like? And then finally, what's the threat of new competition? New companies coming into our space. How does this phenomena affect the barriers to entry? Does it make them higher? Does it make them lower? Does it expose us to new kind of entrants coming into our business or not? So what we did in this body of research over, again, multiple years now is look at a lot of industries in which smart connected products were getting going and started asking ourselves, how's this going to net affect? What are some of the key considerations in terms of industry competition? And like in every other, situation here, every industry is different. There's no one pattern here. But hopefully if we start to get some insights here, we can understand how to think about our industry and what's likely to happen there given this framework. So that's what I'd like to spend a little bit of time talking about now. Let's start with the good news. Let's start with the things that smart connected products do or create or affect that actually should make businesses more attractive and potentially more profitable. And one of them, of course, is that, as Jim was talking, you were probably already sort of overwhelmed with how many new things a product could do in this world than we could do before. And when we can differentiate better, when we can distinguish our product, where we have more opportunities to create distinctive features or combine features in different ways or functions in different ways, that's good. Differentiation connects us more tightly to our customer, usually reduces our price sensitivity. So that's a good effect. Our ability to segment is dramatically improved. With the data that we have from smart connected products and the flexibility of affecting how they operate, we can segment markets and customers in ways that we could never even dream of before. Most traditional segmentation is very rough. Here we have rigorous data, and we can look at exactly how this customer uses the product versus exactly how that customer uses the product, and we can start to see, wow, those are different segments. And we can tailor and customize, for those different segments. And that's good, because once again, that creates more value for the customer. The product they get is not the average product, it's the product that best meets their particular segmented needs. We can hopefully get a good premium price for that. And by segmenting in different ways, we can distinguish ourselves from our competitors. So that's a good thing. Smart connected products shift the supplier base in a fairly profound way. Hopefully, as Jim was talking, you started to feel like that all of a sudden you can have fewer mechanical differences while getting very large product differences. John Deere is a good example. They have a tractor engine for one of their farm tractors. And that tractor engine is identical mechanically. But through the software and the control system, they can run that engine at 4 different horsepower levels. There's no mechanical differences. The different horsepower is driven by the software. So what you can see is you can reduce the number and variety of mechanical parts. Imagine a control system which is a touchscreen control system or a heads-up display type control system. Think of how many dials and wires and things you've eliminated in the product. So there's a mechanical simplification possible, a mechanical standardization possible. That's going to give you more clout and the ability to buy more cheaply, those mechanical parts. Now, the IT parts, that may be a different story. We'll come back to that in a minute. We see opportunities here to shift rivalry away from price. Businesses that have been commodities in the past can decommoditize because of the extended capabilities that are created here. So we may be able to get competition away from price. And we know that if we want to have an attractive industry, if competition is heavily dominated by price, that's not such a good place to be. Hard to make money in that world. Race to the bottom. But these products give us some opportunity to perhaps change that if we're clever and effective and efficient in seizing it. Channels create an interesting opportunity here. With smart connected products, we may not need our channels in the same way we did in the past. Tesla's an extreme example. They sort of eliminated the dealers. The dealers, are really mad about that. But they've done it over large parts of this country. Why don't they need the dealers? Because, first of all, they can fix a lot of stuff remotely. They don't need the dealer to do any configuration and stuff. That can all be done, quite effectively in a much more cost-effective way. If they actually need to bring the product in, they can actually schedule that with the customer and have much fewer sites in which they can do repairs to the extent that they have to physically do something at the vehicle. Channels are often really powerful. They're between you and the customer. And what if that relationship can fundamentally change? That is an opportunity to really improve the attractiveness and the value that you can create in your business. Now, if you're a channel, it doesn't feel so good. So channels have a lot to think about here in terms of what's their role going to be in this world versus the manufacturer. In general, barriers to entry are likely to go up here. Why? Because you've got a much more complex, multi-technology product development process. It's hard to put all these disciplines together, to create this technology stack that Jim talked about with stuff that a manufacturing company's never had to do before. And there's a lot of fixed cost of putting together a smart connected product and the operating system in which it works and mastering all these technologies and getting them embedded in the product. So the kind of the table stakes of being in that business tend to go up. Now, once again, though, although that may be the typical, there's another side to that equation. We'll get to that in a minute. There's opportunities for new business models. Now that you know what's happening to the product every minute of every day, and you can actually affect how it's serviced and the optimization of its serviceability, we're seeing companies now able to move to product as a service or hybrids of that in between. You don't pay for the product anymore. You don't have a one-time sale. You don't have a transaction that's finished. You put the product in the customer's factory, and they pay you as they use it. And those business models can be a plus too. They can allow you to capture more value. On the other hand, those kind of product as a service business models also allow the customer to give it back and say, I'm done, so I'm not going to renew. So there's kind of a plus minus there. Are new business models a good thing? Are they a bad thing? It really depends on your business, your customer set, how your product is used, and we'll talk about that. That's going to be a strategy choice that we'll get to a little bit later. Do we want to change the business model? We also, the customer in the smart connected products world has more visibility of the product too. They have the data. It's their data. They have the right to see what's happening with that product. And if the product is being used 1 hour a day, they're going to know that. Sooner or later, they're going to know that. So that greater visibility may actually depress our ability to capture value. Because value that everybody kind of waved their arms and said was there wasn't really there. So that visibility is a potential negative, but it also could be a positive. That visibility could show how wonderful and differentiated our product was versus the competitors. So the visibility could be a good thing, could be a bad thing. As we build smart connected products, we're going to simplify the mechanical part. We're going to expose ourselves to potentially very powerful suppliers of the technology, the IT. And particularly during this intermediate phase. Over time, it's going to be more available. People are going to be doing more in-house, but increasingly IT becomes a key component. And when you're buying stuff from people like Google, and those are tough suppliers. So the supplier issues are something that we have to consider as we go down this path. Substitution. What's a substitute that gets created by smart connected products? Well, the answer to that is, in many cases, sharing the product with somebody else. And that substitute can be very, very effective for the customer, because the customer only uses the product when they really need it. But it may not be so great for the industry, for the manufacturer, because if you're sharing the product, you're going to need less products. And that raises the question of, should we be in the sharing business rather than selling products, which is what we've been doing historically. So that's another choice that we'll talk about. The higher fixed cost of fielding these kind of products and maintaining the cloud and keeping everything running is going to create some pressure for price cutting. When you got high fixed costs, that tends to give companies a lot of incentive to shave that price, to get a little more volume, to amortize those fixed costs. We're going to have to worry a lot about that with smart connected products. And there's going to be a tendency for kind of a feature function arms race. There's like hundreds and hundreds of things that you could do with your product. Which of those things are really value adding? Which of them will the customer pay for? Sorting all that out becomes a complicated question. We've seen lots of mistakes as we've looked at many industries here. And then finally, although the barriers to entry may be higher in some respects, if you're not careful, somebody that's a whole different kind of company may end up coming into your business. I mean, Johnson Controls saw that with Nest. Johnson Controls had a very strong position in, thermostats for houses and buildings. And this company came out of nowhere and got into the thermostat business. Why? Because they did it differently. They did it with a smart, connected philosophy. And they were able to break in that industry and at least make some waves in that industry. So when you've got these new products and you're a traditional manufacturing company and you're going through the transformation to become one of these kinds of manufacturing companies, then there may be new guys out there that you never thought of that might be competitors. And so we've got to think about who they might be. And we'll talk a little bit more about that later. Now, one other very interesting thing about competition and the effect of these products, these types of products on competition, is the question of what then is the industry that you're in. Defining what business you're in is a really classic, crucial strategy question. And we've long known that. But what's happening with smart connected products is it's, in many, many cases, expanding the boundaries of what the industry is. And this example is a good example. This is a farm tractor. I mean, way back when, there were mechanical farm tractors. And you were in the farm tractor industry. And then those tractors got a little smart. They got maybe some sensors and some software in there that made those mechanical tractors work better. And then maybe they added GPS so they could kind of stay exactly in the same place or follow the row exactly, or the functionality improved. But you were still in the farm tractor industry. You were in the smart farm tractor industry. And then you connected that farm tractor to the internet, and you were in the smart connected tractor industry, and you could get some information off the internet around weather conditions or whatever that could allow your tractor somehow to get some improvements. Okay, so you're still in the tractor industry. But with smart connected products, the tractor is no longer sort of a standalone thing anymore, because there are other machines that are working with the tractor, the combines, the tillers, the planters. Wouldn't it be more efficient if the tractor and the planter were somehow connected together and optimizing the way they both work together? So that the planting was more efficient, or the location of the furrows when the depth was optimized and whatever. But it could go even further. What if you wanted your tractor and your planter to work with the irrigation system and control and optimize the use of water and irrigation depending on the conditions in the soil, and had it just been plowed, and how to do the water, optimize the water with the planting, and then maybe the seeds become part of the system. Which seeds should we use given these conditions, given this moment? You can start to see all of a sudden we're not in the farm tractor industry anymore. We're in, let's call it the smart farm industry, or the farm machinery industry. And all of a sudden, when the boundaries of your business expand, what that means is you've got some competitors you never had before. And you're competing really to optimize the system. You're not competing just on the features and functions of your tractor. And we're seeing that happening in lots and lots of industries. Building control systems, combining, HVAC and water heating and all kinds of other things into really a connected, smart building, in which there's a lot of mechanical equipment that has to come together to optimize that, or a connected home, where you've got your thermostats and your lighting and your security system and your door opening system and your whatever, and those things are all kind of needing to work together. And if they're designed to be optimizing across the various pieces of equipment, then they might work better together than your individual component works, even though that was the gold standard, traditionally in the industry. So industry definition broadens. We see very few cases where it's narrowing, it's broadening. And the question you've got to ask yourself is, okay, what system am I now part of? And I can actually be part of multiple systems. And what products am I now somehow tethered to or need to think about how to optimize with? This is a question we haven't had to answer in most industries ever. And yet now we're seeing company after company have to answer these questions. And going back to the 5 forces, this adds some more dimensions to competition and to choices. For example, all of a sudden you can embody functionality in a system and disintermediate an individual product. Think of, historically, you wore a watch to tell the time. You had a pedometer to measure how many steps you were taking. You had a phone. And you're increasingly seeing products that are pulling together multiple functions that used to be separate into single products. There's not much market for pedometers these days. They've been superseded. They've been substituted for by a system. And that can happen. On the other hand, you may be the one who's substituting for many other products with your system that you're part of. So it can be a plus or a minus. Rivalry is changing. It's not product by product. It's almost system by system. And sometimes you can be just a product guy and have the best product and be compatible with all the systems, but sometimes you can't. And that's going to be a key choice that Jim will talk about later. And then finally, some of the most likely competitors you're going to be facing are companies that are now in some other product that used to be a separate product, but now it's connected to the system. And all of a sudden, then, the potential entrants could get much more scary than some new little guy having to come into the industry. So that tries to give you a flavor for the competitive environment, the nature of competition, some of the discontinuities that are underway. Now let's, Jim, talk about strategy. For an individual company, how do you navigate this in order to get an advantage for your organization?
Great, thanks, Michael. So another fairly well-known teaching of Michael is that there's really 2 parts to strategy. One part is to be operationally efficient in parts of your business where you're not really trying to create a differentiated competitive advantage. But then the other part is to be unique and remarkable in the areas where you're trying to differentiate, and of course to understand which is the first test. But it turns out that smart connected products have a huge impact on both. If you think about smart connected products and their impact on Industry 4.0 manufacturing or their impact on more efficient service, it's a huge operational efficiency. Probably you won't win because you can service your product better than your competitor. I mean, maybe, but probably that's just an operational efficiency that'll give you a higher margin. But at the end of the day, in the areas that aren't core to your differentiation strategy, you really just want to be sort of adopting best practices. You want to be, best in class or sort of equal to best in class. You want to be at the productivity frontier. Just a simple example. Most companies don't think of accounting as a competitive advantage. So when you say, like, how should we do accounting? Let's do it like everybody else does. With a modern system, maybe an ERP system, what have you, adopt the best practices because we're not trying to differentiate there. Probably Babolat's not trying to differentiate with accounting. But they are trying to create a unique product. They're trying to create a product that has a proposition to the end customer that's fairly unique. And they're also using Internet of Things or smart connected product technology to do that. They're creating a whole new set of features. You can analyze your game. You can rank yourself according to peers. You can understand what you're good at and what you're not good at and use that to get better in your game overall. This is a huge competitive differentiator. I don't think that Babolat prices this product the way they'd have to price a sort of standard, if there is such a thing, tennis racket. It's a very much differentiated product. And that said, they're probably using traditional ERP systems and other things to gain operational efficiencies. So part of strategy is really understanding where are you trying to differentiate and where are you trying to be at the productivity frontier. And it turns out that smart connected products raises a whole bunch of new questions that companies never had to answer before. This is the first time through. And unfortunately, it's not like a test because these questions don't have correct answers. They sort of are strategy choices and trade-offs. And if anything, you're looking for a combination of them that make sense together. So let me take you through 10 new strategic questions that companies are asking for the first time. So which capabilities to pursue? I mean, that's obvious. There's so many things you can do with smart connected products. I mean, you could take this tennis racket idea all kinds of places. But you have to ask, will people pay for it? Because all of these great features, if I go back to monitor and control and optimize and automate, that all costs money and time to put in there. Will I get paid back for it? So I got to be careful not just to get into a blind feature race, adding more and more technology to products that doesn't create enough value and differentiation with the end customer. The second question is, should the functionality be embedded in the product or the cloud? And it turns out that's actually pretty tricky. And a lot of people are migrating stuff back and forth. So for example, with this tennis racket, when I play tennis, the data migrates up to the cloud. I then connect to the cloud on my smartphone, and I analyze my game. But I could have a system in the tennis racket where every time I do a stroke like I'm not supposed to do, the thing buzzes or something. It vibrates like my cell phone does when I get a call and say, Jim, stop doing that. So I could actually put some of the analysis and feedback loop right into the product. Now, there's a lot of questions, how much data would I have to move back and forth and how much compute power, and if I put it in the product, then I need a bigger battery, and there's a whole bunch of technical trade-offs, and there's some other trade-offs as well. The next question would be, do I want an open or closed system? And of course, as a CEO of a software company, everything should be open, but it's actually a little bit more nuanced than that. So let's say Babolat says, our system's going to be open. Well, great. Then I can hook your tennis racket to my cloud instead of to your cloud, and I just disintermediated you, that whole relationship with your customer. So it actually turns out people are saying, we'll slow down a little bit here. I'm not sure everything should be open. It depends on my strategy. If Babolat, and I'm just hypothesizing, if Babolat wants to come out with a whole family of products that share a cloud so that they have the connected line of sports equipment and all the applications that go along with it, they're going to want to encourage you to buy them all, just like Apple does. Apple's the most closed system on the planet, but you buy it all because it's very frustrating to have a Windows laptop and an Android tablet and an iPhone and something else. It's just frustrating. So by keeping it closed, they can optimize it a lot more. And all the Apple products work together in pretty amazing ways. So a lot of people just adopt the whole line. The Macintosh, the phone, the tablet, maybe even the car. That's going to be the selling proposition for the Apple car if and when this thing comes out. It's just going to be an extension of your Apple life. And that's why you're going to buy it. Now, they don't want people to intercept that. So this open versus closed is a lot trickier than you think. Now, on the other hand, Babolat could decide, we're never getting into other kinds of sporting equipment. We're never going to make golf clubs, for example. But somebody has built a great application that analyzes tennis rackets and golf clubs, and if we're not compatible with it, people will stop buying our tennis racket. So then we better be open, right? So it's very nuanced and sort of a tricky question, very circumstance dependent. Next question is, all that new technology, should we build it ourselves or should we turn to people for help? And I've been around the block long enough to know that the first reaction of every IT department is, we're going to build that for you. And it's sort of like every other major information system we ever had. The first generation was homegrown, and then later we had to rip that out and replace it with something off the shelf. I mean, most companies had homegrown MRP systems that they later replaced with SAP. A lot of companies even had homegrown CAD systems. And what started out as an advantage became a very expensive liability over time. So I think this one's tricky, and really the question is, where can you add value that's above and beyond what the industry can do better, right? So pick your fights would be my advice, and make sure that anytime you've got developers writing software, they're doing something special that you couldn't just buy from somebody else off the shelf. The next question is what data to capture. What types of data, how frequently. A lot of sensors, can be read 40,000 times a second. But do I need to send 40,000 readings per second from each sensor up to the cloud? Probably not. Maybe I want to downsample it and send just a few readings. Maybe I want to do some local processing to convert accelerometer and gyroscope readings to strokes and send strokes up to the cloud. So there's kind of a tricky question around what data do I want to process on the edge in the product? What data do I want to send to the cloud on what frequency? And then that brings the next question. If you're going to start moving this data around, you have to protect it. And how are you going to do that? So how are you going to manage security, privacy, access rights? If you're going to take this data and assume control of it, you're also assuming a certain level of responsibility for it. So you're going to have a good strategy for that. Question number 7 is, would you rethink some of your channel partners? One of the main reasons a lot of companies have service partners or distributors is to be close to the customer. But with smart connected products, you are digitally closer than ever before. Every time I take a swing. That's pretty close. So maybe, like Tesla, you could imagine a world where you don't have dealers. Now, you have to be careful because those dealers could be adding some other important value. And it might turn out that, you end up kind of painting yourself into a corner by going to war with distributors or service dealers that you actually need. Question number 8 is, should you change the business model? I would imagine that, like cars, tennis rackets aren't that utilized. Now, I'm being a little silly here, but could you sell tennis rackets by the game? Maybe. Use my racket, play a game, download your sort of scoring of your technique to your phone, and go home. And when you show up tomorrow, there's a special rack, and you pull the tennis racket out of the rack just like you do with the bicycle, and you play another game. Now, I don't know if that'll happen, but it could. And I think there's probably been lots of discussions today about new business models, and particularly new business models where new efficiencies are being generated, either through much higher levels of utilization or perhaps through much more efficient service, and you don't want that value to be captured by somebody else, so you want to change the way you deliver your service to capture back some of that efficiency that you helped generate. Again, if we did sell, by sell I mean, let's say, licensed smart tennis rackets by the game, the world's not going to need as many tennis rackets. So how am I going to make money? I'm just going to make fewer tennis rackets. So it's a tough question. Question number 9 is, should I sell data to outside parties? So I have this data, and it's a very valuable asset. And using it in my business generates value. Sharing it with my customer generates value. But there might be other people that get value from it, too. I could imagine that, there certainly would be some competitive dynamics around tennis. Do you want to know how this other player plays? Because I know how they play. Now, I got to be careful because I might make them very angry if I sell you that data, but I have it. And depending upon what that 18-page EULA agreement said that nobody ever reads, maybe I can sell it. Maybe I can anonymize it and sell it. There's just lots of different ideas. A good example is one of our customers makes smart signs, the kind of signs that sit by the edge of the road and blink, you're driving too fast, slow down, whatever. And the message that gets delivered, of course, has to be customized all the time, and it has to be configured for the local speed limit and so forth. So they used to have to go out and visit all those signs and set them up. Then they connected them all to the internet so that they could remotely reconfigure them all. Well, it turns out those things are measuring traffic velocity and volume. So they're traffic meters. Who wants to know what the traffic is at this site? Maybe I could sell it to the local government or something like that, and probably the drivers driving by have no right to that data, and I don't even have to ask their permission. So there's lots of interesting ways to think about monetizing the value of data beyond its original primary purpose. And then the last thing is, should you expand your product scope? Should I think about where could I go with this idea of connected sports equipment? Should I get into the golf club business? Because some people would like to analyze their golf game in the exact same way. And I could take this differentiator and move sideways. And I might run through a calculus on can I be successful with that or not. So these are new questions that people have to answer. There are, like I said, no right and wrong answers. They're tough questions. I think a lot of people start down one path and then say, that was a lot harder to get into the golf club business than I thought it was going to be, and so now I'm backing back out of it. So there's a lot of false starts that have happened already with people, but they're tough questions. I think the key thing is to look for some configuration of these things that make sense together. Random decisions that don't align probably lead to a business that doesn't really work that well. Now, I want to talk next, Michael and I want to talk next about how does this affect what happens inside a company. And it turns out Michael published a very famous framework. You may not know that Michael Porter here invented the term value chain in a book he published in 1985. And I think if he had a nickel for every time anybody in the world used value chain, I think he's actually doing okay, but he'd probably be, he'd probably even be doing better. Because it's a very famous concept. And he published a framework that says this is the way you can think about the activities of a firm, how they take inputs, add value, and create products and services that are delivered to their downstream customers. And it's a pretty good framework because 30 years later, it still works pretty well. So we use this framework, and basically every part of a company is touched by smart connected products. We don't have time for every part today, but we'll focus on a few that we've highlighted in green and step through what are some of the implications for products, for value chain activities because of smart connected products. And I like to start in my favorite place, product development. So the first thing is that products are becoming very complex technological systems. The engineering department is going to have to adopt system engineering practices, and they're probably going to have to reach out to the IT department and say, how do you build all that cloud stuff, or help me figure out who to buy it from and how to put it in place and make it work, because I can't ship the tennis racket if the cloud doesn't work. And I never had that problem before. So there's some very big differences in product architecture, like I talked about, and in process. But there's also some new design principles, like the idea of moving variability from hardware to software. Michael mentioned this tractor engine example. You could say I'm giving too much tractor engine to some people, but then again, I don't have to have 4 different engine blocks, 4 different sets of pistons and rings and connecting rods and spare parts for all that stuff for the next 30 years. I mean, it's actually a lot more efficient to ship one engine and derate it to people who don't want to pay for the full horsepower. Maybe even circle back later if they change their mind and twiddle some bits and charge them for the bigger engine. It's a nice business model if you can do it. So moving variability into software, that's kind of what Apple did with the iPhone. The iPhone has many fewer mechanical parts than any predecessor phone. If you think of the keyboard on a BlackBerry, I kind of like that keyboard, but there were tactile keys there, physical mechanical keys that were produced in assembly lines and then assembled into phones. That doesn't exist anymore. Now we just put a digital keyboard on a piece of glass and say, make it work. Which means we can change the language on the keyboard. We can do all kinds of things like that are interesting. We can also make evergreen products. And by that I mean products that are never done. It's kind of fun, this tennis racket example. In doing a little bit of recent research, it turns out that this tennis racket can't tell the difference between a ground bounce ball and a volley that came over and I hit it right out of the air. It can't tell yet. But they've figured out an algorithm that can tell. So if you do a little software upgrade, your tennis racket just got better. So the idea of the tennis racket can change, a year or 2 or 5 after it left the factory. That's a pretty interesting idea. Tesla did this recently with their autopilot. They said it's not quite ready, but it's actually pretty useful, and it'll get better over time. So we're going to start selling it. It's like version 1 of a software product. Buy it, use it, and it'll get better. There are some other ideas like different types of design for service or business model. If you look at the bikes in this picture in the upper right, those kind of sharing bikes, designed for sharing, they look very different. Why? Well, because they're used very different. And they're optimized for the way they're used. And so there's a whole different design approach if you're thinking about designing for a different business model. And then one other fun thing, and we brought an example here, would be new types of user interfaces. Can I just give you that for a second? So remember earlier I talked about dashboards, how you could augment dashboards onto things? So just to make it more real, I brought a dashboard. And this is from a Ford F-150 pickup truck from some years ago. And in this original dashboard, there were physical dials and gauges and big wire harnesses coming out of the back and so forth. And what's state of the art right now is to put in a big computer screen. And you can get rid of the physical dials and gauges, and you can get rid of the wire harness and just feed in a digital signal through a RJ11 jack or something like that, I suppose. But what's very interesting, if you think, where could I go with that? And so this particular dashboard just has a piece of cardboard here with a logo on it. And so I'm going to fire up a piece of technology we call our Thing browser. And when I point this Thing browser at that dashboard, it recognizes the logo and replaces it with a pretty interesting looking dashboard showing live data. Now, it's not really live data, but you know, the gauges are moving and so forth using simulated live data. And because this particular dashboard is purely digital and virtual, I can change it as simple as 1, 2, 3. So if you look at the bottom, if I hit the number 2 button, it looks like that. And if I hit the number 3 button, because I'm in a different mode, it looks like that. So this is an example of where I'm augmenting a human-machine interface, a dashboard, onto something that doesn't have any native way to display information. I'm adding that to it. That changes the bill of material of this product a lot, and it changes the development process for developing such a product as well. So that shows you some of the ways you might think about product design differently. Let's go on to how you might think of manufacturing differently. Well, there's 2 ways to think about the impact on manufacturing. One is your factories and production processes could be more efficient. Industry 4.0, smart manufacturing, what GE calls brilliant factories or brilliant manufacturing. There are a lot more levels of optimization of uptime and process that can be implemented by adding more control and optimization loops into what a factory does. We talked about how you could reduce physical complexity, and every time you do something in software, you can also do it at the last minute. So one of the things about an iPhone, if you just think about it intellectually, it is certainly in the early days. I mean, there are more versions of it now, more colors, more sizes, and so forth. But in the early days, it came with, I think, 2 memory configurations and 2 colors. Yet if you sat in a room like this and you had everybody pull them out and compare them, they were all very, very different. Why? Because the last step of the manufacturing process actually happens at home, when we log into the App Store and load it up with all the capabilities that make it my phone. So we actually pushed the final step of production so far downstream, it's done in your dining room now, sitting at your table or in your office or what have you. So that's a big advantage. You don't have to carry near as much half-done work in process inventory that's got the wrong configuration. Everything gets configured very, very late in a much more efficient process. The second thing, though, is that the whole nature of manufacturing changes. So I do a lot of business with companies that are in discrete manufacturing. I think at some point there will be no such thing as discrete manufacturing. Why? Because with a smart connected product, you're never done. Why are you never done? Well, first of all, there's a part of it in the cloud that keeps on running. That tennis racket is running right now in the cloud. Even though they manufactured the physical part, they're still running the cloud part today. The second thing is it's evergreen. I can keep changing it. I can keep making it better and different and adding features and so forth. If I come out later with the golf clubs that share the same system, I can tie the 2 together and it's more valuable. So it's a different notion where discrete processes that used to terminate cleanly don't terminate anymore. They're open-ended. And this, you're going to see, has a big implication for the way that companies are organized. Because who's going to run that open-ended process? That's something that we're not really set up to do. How are we going to do that? It's going to be an organizational issue you'll see later. The next thing is probably the place where the biggest, most obvious changes happen. I often say that service is the killer app for IoT or smart connected products. Why? Because the way service is done is terribly inefficient in most cases. And it could become much more efficient. We could make service preventative rather than break fix. We could make it remote rather than on-site. We could do all kinds of interesting things to optimize inventory levels if we knew a week in advance when things were going to break. We could carry far less inventory and we wouldn't have to spread it all over the world because we'd have time to move it to where it needed to be. So there's some really interesting ideas about how service can get more efficient. I can upgrade the whole fleet of Teslas and put a better autopilot in place by pushing a button. That's an interesting idea. I can analyze warranty data. You can file a warranty claim and say, there's no way I'm going to pay that. I've been watching how you use that product. You're way outside the warranty limitations. You know, everything has a limitation on the warranty. So there's many, many interesting ways we can use digital proximity to make the service process much more efficient. And then, of course, that raises the question, does that mean the customer pays me less for service? because I used to make a lot of money selling spare parts, and now I don't consume as many spare parts because I figured out how to make the design better. So my spare part business is plummeting, thanks to all this great technology. So that leads you to the question of a different business model. We had one more demonstration I want to show you here of a customer example, one of our customers, Sysmex, how they created a service application that makes service very efficient. And if you could bring that video up here. Okay, so this particular piece of equipment, is a Sysmex XN1000 blood analyzer. So if you go to the clinic and they draw blood out, they put it in a tube and analyze it in this machine. And this guy is not a service technician, he's a blood analyst technician. And he's using a tablet to do an analysis of what's wrong with this machine. The iPad said, run this cleaning operation. He tried that, it didn't seem to fix the problem. So now we're going to say, okay, rather than send a technician, I think I can coach you and instruct you through this. So he looks at the machine, with his smart glasses on ideally, but in this case through an iPad, and that on-off button starts to blink, because step one is you got to turn it off. So he says, okay, I got it. Now if you kind of watch, step two will come up. He'll say, okay, I did that. By the way, I'm confirming he's doing these things too, which is sort of interesting. And so step two is remove the RBC aperture cover, just like this. Just take that out, then take this piece out. And now the next step is going to be take a swab of some sort of like a pipe cleaner, and stick it in there and wiggle it around. And then when you're done, pull that out, and now we're going to put it back together. So put this part in there and twist it back just like that. And then put this RBC aperture cover back in place and tighten up the control knob. And turn the machine back on, and you're in production. So this was sort of an interesting way where we empowered a non-service technician to do a procedure that he's never done before and would be intimidated to do, but we were able to step-by-step show him how to do it, and quite frankly, we could have coached him through it as well. So that's a fun example. I'm going to turn it over to Michael, and we'll wrap up by taking a look at a couple other parts of the organization.
Great. Well, we have negative time at this point,
okay.
so I'll move quickly, Jim. But I think you've gotten, hopefully, a good flavor for these ideas and how to start thinking about these kind of products and what they can do. Just quickly, and we'll make these presentations available to any of you that are interested. On the marketing side, the whole nature of the customer relationship in this world is a different relationship. It's not about selling a product, doing a transaction, and then being done. Because you're tethered to that product, you're tethered to the customer, you can monitor what's happening. All of a sudden, you have truly a relationship with that customer, and it's your job to make sure the customer is getting the maximum value out of the product. And as we'll see later, that's affecting organization. Traditional sales forces don't do that very well. They're good at selling, doing the transaction, getting their commission, and going on to the next customer. But somebody needs to make sure that the customer succeeds, the customer gets the new features, the customer does the customization that would help them get more value. Somebody's got to make sure all that happens. It's a different customer relationship. And I think it's already been clear, but the people involved in all of this in the value chain are changing. The typical manufacturing firm does not have the people, enough of the people with the skills that can do many of the things we've been talking about. And again, this slide just talks about how what's happening is manufacturing companies are becoming kind of hybrids of manufacturing and software companies and data analytics companies. These things are coming together. The kind of skills and how they work together is evolving, and that's creating lots of challenges. And it's hard to find some of these skills in Peoria, not to pick on Caterpillar. So we're finding that manufacturing companies are having to source different kinds of talent, often from different locations. Some cases they're establishing locations in the talent pools. We have a lot of things happening in Boston now. This has become a hub in this area. A lot of companies are coming to Boston now to do this kind of work because that's where the talent is. So HR is significantly affected as well. We have no time to really go through the details of organization, but as I said earlier, the big message is that we've had a very stable organizational model for a manufacturing business historically. the classic functional structure. You separate the organization into the functional units. Those units do different things. That's why you set them up as a separate unit. And then they have to coordinate through various kinds of mechanisms to kind of pull together what the various functions are doing into an overall strategy. And to manage the handoffs well between marketing and sales and development and so forth. That's the traditional structure. That structure, though, doesn't work so well for what we just talked about. The work that's necessary to kind of create and then deliver and manage these smart connected products. Here's some of the key changes that we're seeing companies have to make. Number one is to kind of unify the data. We can't let every function keep a little bit of data. We need a way to gather the data. And we need to set up a new organization in many companies that's responsible for this data and the analytics capability of the data. That doesn't mean they don't work with functions, but that expertise is not something we can sprinkle around across every department. There's a new C-suite officer, the kind of chief data officer, that is now popping up, more and more rapidly within manufacturing companies and other companies as well. So that's one change. Another change is the need for deep collaboration between IT and R&D. IT traditionally has been infrastructure stuff, your operating systems and your websites, and R&D has been all the cool technology in the product itself. Now those things are just merging, the skill sets are merging, and we're seeing very different relationships between R&D and IT than we've seen historically. And sometimes that creates a lot of tension, and turf that has to be dealt with. So that's number two. Number three, we've got to have somebody that's paying attention to making sure that this cloud and this infrastructure is running smoothly and the upgrades happen and the product enhancements happen smoothly. We can't bring down all of our products around the world because our cloud fails. I mean, literally, the products won't work without the cloud, or they won't work well. And so somebody's got to be managing that whole cloud infrastructure and managing all the releases and the upgrades and the customization that needs to flow through that infrastructure. And the sort of name that's developing for that group, which is usually a different group than manufacturing or IT, is so-called DevOps, Development Operations. Somebody that's kind of a bridge between the developers and the customers to kind of make sure all of this stuff works. And then the final thing we're seeing is, given my previous comments about the customer relationship, we're seeing companies stand up groups which are sometimes called customer success management groups. And these are groups that are responsible every day for making sure the customer is getting value out of the product. And we can, of course, tell what they're doing with the product. We can tell how they're configuring it. We can tell how it's being used. And we have to then accept responsibility for managing that relationship so the customer is happy, takes advantage of the functionality. And a typical salesperson and a typical marketing person, that's not what they do. And it's not clear they should take on that role. So we're seeing companies stand up new organizations to do that. This is all very early days. We don't yet have a clear model for just how this organizational model is going to look, but it's really quite striking. As a business school professor, I can tell you that it's been a long time since the very core organizational model of a manufacturing company has changed, and we're starting to see that now. We believe that we're in the early innings of this process of seeing smart connected products sweep over the economy. We think this will have a tremendous impact on value creation for the better. There's a lot of value opportunities here. Doing things, more efficiently, servicing better, getting better usage out of the product, using fewer raw materials. All kinds of optimization advantages are possible here. The numbers are gigantic. Nobody knows what they really are, but the value creation opportunity is clearly going to be gigantic. We already know that. This is transforming competition. I hope we've given you some ways of thinking about how that's happening, and it's moving into service industries. We have lots of examples. We'll probably have an article on that soon to talk about how this changes a service company, a maintenance company, an airline, a transportation company, a accounting firm. And so service industries are changing as well. There's going to be some dislocation. There's going to be some disruption. But we believe the net effect is positive. That is, the innovation possibilities are exploding so fast that even though there's going to be some disintermediation and some substitution, net, we think the opportunity expands. There'll be more needs met, more people will have more of their needs met, and the net effect will be positive for growth, certainly for productivity improvement. We expect another spurt of productivity growth to already be kind of building up for taking root. This is going to be good for the human condition, this whole thing. We're going to be able to conserve resources, use water better, improve health, improve safety because we don't have to operate products in dangerous places. We can do it remotely, through the cloud. It's going to help us in using energy better. It's going to allow us to share products rather than to have throwaway. We're going to upgrade things rather than put them in the junkyard. The human condition will benefit from this, and that's really exciting. And I think a lot of people are starting to feel that. It's going to affect jobs. It's going to probably eliminate some jobs, but it's going to create, we think, many others. Did you see that last demonstration where some guy that had no idea how to fix a product was fixing it? Well, you can use this same technology of augmented reality to provide training in ways that we could never dream of. You used to have to go to community college for 2 years. Now, with this technology and the coaching you can get, I think we can equip people to do good, productive work much faster and much more effectively than ever before. We can break down the traditional training model that has been so hard for us to adapt and keep up to the needs in the economy. So we believe that the net effect on growth and jobs will be positive. There'll be dislocation, but there's going to be many new things created. And the final thing I would tell you is that I think that this is an opportunity for the United States to resurge. We're in a very, very difficult time in our economy. Our productivity growth is not good. We look good compared to, the walking wounded around the world, but ultimately in absolute terms, our economy is growing very slowly. Wages are not growing. Growth is low. We have a little uptick, but things have been like this now for a decade. And I think what the great opportunity we have is to take advantage of this opportunity of smart connected products to start creating another wave of innovation in the economy again. And it's happening already, and we think it's only going to accelerate. And we think the U.S. is particularly well equipped with the combination of some great manufacturing companies, but also with an enormous IT industry. And a lot of the technology that we've been talking about today is very deeply developed and growing here in the U.S. So I think this should be good for America. But it can be good, it'll be good for every country because of the opportunity it creates for innovation and growth that we have not seen in some time. So thank you for your patience. We hope this has given you a kind of a way of seeing holistically what's going on here. We've sort of tried to dig into the details, but hopefully stay at the level of kind of strategy, competition, value chain, and organization. These slides will be available to anybody who wants to download them. Please look at the articles, and anybody who has any thoughts or comments, we're very deeply engaged in this work. We're not done. This is going to take a long time to really fully develop our understanding of this phenomena. We'd love to work with any of you in doing that. So on behalf of Jim and I, thank you very much, and we're so pleased you're here.
Great, thank you.